Good evening. So today we are going to talk about capacitors, how capacitors are made up, or how capacitor stores energy, and how can we connect capacitors into in different ways, and the discharging of the capacitor. So let's begin with a capacitor. So first of all, what's a capacitor? So when we talk about a capacitor, capacitor is very, we can all make a capacitor. Capacitors are something which used to store electrical energy. പക്ഷേ ബേസിക്കലി നമ്മൾ പറയുമ്പോൾ കപ്പാസിറ്റർ സ്റ്റോർസ് ചാർജ് എന്നാണ് പറയുന്നത്. പക്ഷേ ഡെഫിനേഷൻ ആയിട്ട് പറയുമ്പോൾ നമ്മൾ കപ്പാസിറ്റർ യൂഷ്വലി ഇലക്ട്രിക്കൽ എനർജി എന്ന് പറയണം, ചാർജ് എന്ന് പറയാൻ പാടില്ല. ഐ വിൽ ടെൽ യു വൈ ഇറ്റ് ഈസ് ദാറ്റ്. So capacitor എന്ന് പറയുന്നത് we can all of us can make a capacitor if you have got aluminum foil. So കപ്പാസിറ്ററിൻ്റെ അതൊരു അലുമിനിയം ഫോയിൽ എടുത്തിട്ട് മീൻസ് ഒരു കണ്ടക്ടിങ് പ്ലേറ്റ്, അതിനുശേഷം വേറൊരു കണ്ടക്ടിങ് പ്ലേറ്റ് ആൻഡ് അലുമിനിയം ഫോയിൽ ഇങ്ങനെ വെച്ചിട്ട് ഇതിൻ്റെ ഇടയ്ക്ക് ഒരു സ്പേസ് ഇട്ടിട്ടുണ്ടെങ്കിൽ ദാറ്റ് ബിക്കേം എ കപ്പാസിറ്റർ. So capacitors are, you know, there are different types of capacitors. There are parallel plate capacitors, are there, disc capacitors are there. So many capacitors are there, but mainly we are discussing about parallel plate capacitors. So let's talk. First of all, capacitors have capacitance, or capacitance is basically represented by the C. C is equal to Q over V. So capacitance is the ratio of charge to voltage. Charge to voltage is capacitance, and the unit of capacitance is farad. Unit of capacitance is farad. We represent it by using the letter, capital letter F. A capacitor is represented by two parallel lines. So this is exactly a capacitor, but sometimes we can say that this one, if you have got one of the line is smaller, then it's a battery. So make sure that you are using the correct symbol. So capacitors is used, this symbol is used to represent capacitor. Okay, so capacitor is basically two parallel plates separated by separated by an insulator. For example, if you have got a conducting material, let's say that aluminum foil, and then I made the aluminum foil into this kind of a piece and another one. Now this has become a capacitor. If I connect this capacitor to a battery, then I can say that the capacitor will start getting charged. So what is actually happening is, like this capacitor, before it is charging, there is no extra electrons, or else we can say that capacitor is neutral. When the capacitor is neutral, it does not have any extra electrons. It's a, like an atom, we can say that it's electrically neutral. There is no extra electrons. But when you connect it to a battery, we can say that slowly the electrons from the battery will start moving over here. So we can say that the electrons will push. Now this battery will push the electrons onto one of the capacitors. So there will be electrons on one plate of the capacitor. When there are electrons on one plate of the capacitor, these electrons will repel the electrons on the other plates of the capacitor. So because of the presence of these electrons, the electrons over here will be pushed to the battery. So what happens over here? There will be positively charge developed over here. So this right now we can say that there are some extra electrons in the capacitor right now, on one of the plates. If I talk about this one capacitor, this is plate A and plate B. Plate B contains electrons and plate A has an absence of electrons. So because of this one, we can say that there is a charge in the capacitor. So now I can say that the capacitor has become charged. So it's a charged capacitor now. And once the capacitor is charged, completely charged, there won't be any more flow of electrons. Okay, I will explain what happens in this one later on. Okay, so this is how do we charge a capacitor. So once the capacitor is fully charged, a capacitor has got one of the plate will be having a lot of electrons and one of the plates will be having absence of electrons. So when you talk about a capacitor, fully charged capacitor, the total charge on both plates of the capacitor will always be zero. Total charge on both plates. One of the plate will be, if there are 500 extra electrons in plate B, then 500 electrons will be absent in plate A. So the total charge of a capacitor will always be equal to zero. So whenever we are using, whenever you are using the formulas to calculate the capacitance or charge on a capacitor, we actually refer to the amount of charges on in a single plate, not together. If it is together, means the total charge will always be equal to zero. So the capacitor, so parallel plate capacitor will be two parallel plates, and these are separated by a small distance. And we can say that this small distance can be an insulator. Look here, if you put an insulator, it is going to be even better. So two parallel plates separated by an insulator is known as a parallel plate capacitor, and the charge on both capacitors will be same. One will be having a positive charge, another one will be having a negative charge. So this is a parallel plate capacitor. So, when we charge a capacitor, initially I can say that the capacitor plates are empty. Now, when we are connecting it to the battery, and if I turn on the switch, at that time we can say that the number of free electrons in this plate, and if it is plate A and plate B, no free electrons. But slowly, because of the battery, electrons will be pushed onto this. Okay, as the charges are accumulated. So initially, the capacitor plates do not have any charge. So the electrons can move quickly to it. So because there is no opposition force. But as the charges are accumulating on these plates, we can see that there is an opposition force. These electrons will be, the electrons repel another electron. So if an electron is coming from here, this electron will be experiencing a repulsive force. So what happens? The charging is not really easy. Once there is no charge, it can quickly go. But as the capacitor, as electrons get loaded onto the capacitor plate, the charging process will become slower and slower. That's because we can say that once the capacitor plates get electrons, these electrons will repel it will be against the next electrons coming in. So the charging of a capacitor will be slower with time. So initially it will be faster. Then what happens? It becomes slower and slower. And finally, once the capacitor is completely charged, there is no electron flow in this circuit. So this is a very important point. So when you connect a capacitor to a battery, initially there is current, and that current decreases, and finally that current in the circuit becomes zero. When the current in the circuit becomes zero, you can understand that the capacitor is completely charged. So if a capacitor is completely charged, the current in the circuit will be zero. Okay, that's it about a capacitor. Okay, so what's a parallel plate capacitor discuss? What is capacitance? Capacitance C is equal to Q over V. So it is the amount of charge stored per unit voltage in one plate of a capacitor. And capacitors basically store energy. If they are asking us, capacitor basically stores energy because capacitors produces an electric field, and there is work done in moving the charges. So capacitor stores energy, not charges. So sometimes they will ask you a question, why the capacitor stores energy, not charge? Because the capacitors basically, there is when you charge a capacitor, there is work done in moving electrons in the capacitor, or there is a work done against the electric field. That's why should say it stores energy. Another one valid point is that the total charge of a capacitor will always be equal to zero. So we can say that capacitor stores energy. So because capacitor stores energy, because work is done in separating charges. Hmm. And now if you talk about the energy stored in a capacitor, we can say the energy is equal to, there are two equations, half CV square. If you know what is the capacitance of the capacitor and the voltage across the capacitor, you can find out the energy by using half CV square. Okay, why there's a half comes? So here we can say that if you have got a voltage versus charge graph, you know that initially when the charge is zero, there will be a particular voltage. But as the voltage increases, charge will also increase. So here what happens, the voltage is not constant. The voltage is changing. No, as it is getting charged, we need to increase the voltage. As the voltage becomes more and more and more, the charge is also increasing. So since the voltage is not same, so we take an average. That's how it becomes the half. And in the case of a graph, if you find out the area under the graph, if you find the area is equal to half into BH. It's basically half into voltage times charge. But we can say that voltage of anything, voltage is equal to energy over charge. So we can say that is half into energy over charge into charge. So it's basically, it gets cancelled. So what we get is the area under a voltage charge graph. The area under a voltage charge graph is energy stored in the capacitor. Energy stored in the capacitor. So, but we know that C is equal to Q over V. We can put this one in this, replace the value of, replace C with Q over V. So E is equal to half into C can be written as Q by V into V square. So V square and V gets us. So energy is equal to half QV. This is also another one equation. And we can say that energy is equal to Q square over V. Energy is equal to half into, I can write here what E is equal to half CV square. So half into C is Q over V, half QV. Then we can say that instead of V, you can write Q over C. So energy is equal to half into C into Q over C all square. So which is Q square by C square, and this one cancel. So energy is equal to half Q square over C, half Q square over C. So there are three equations of energy of the capacitor. The main equation is half CV square. Energy of the capacitor is equal to half CV square. Energy of the capacitor is equal to Q square over 2C, and energy of the capacitor can be found by half into Q into V. That's also fine. Okay, next one is how can we connect the capacitors? Okay, I forgot to tell you one thing. When we have got a parallel plate capacitor, the capacitance of this capacitor is basically depends upon capacitance C is equal to epsilon 0 A by D. ഇത് നിങ്ങൾക്ക് പഠിക്കാനില്ല പക്ഷേ what are the factors on which the capacitance of a capacitor, parallel plate capacitor depends എന്നൊരു question വരുവാണെങ്കിൽ it depends upon the permittivity of the medium. So this is basically two parallel plates. So between the two parallel plates, there will be a medium. So depends upon the medium, the capacitance change. If it's a very good insulator, there will be greater capacitance. If the capacitor is, if the capacitor does not have a good insulator, then the capacitance will be lower. And the next one, the capacitance also depends upon the area of the capacitor. So if this one has got a greater length and greater breadth, then we can say that the capacitor will be greater. Another one thing which depends on the capacitor is the distance between the plates of the capacitor. So there are three factors or two factors on which the capacitance depends. If the length, it depends upon the area of the capacitor plates. If the area of the plates are more, like a greater length and a greater breadth, it will be having greater capacitance. And if the distance between them is smaller, then there will be greater capacitance. So the capacitance depends upon these factors, which, you need to keep it in your mind. This equation is not there for you, but you can, you can study so that you will get some idea. Okay, now we can connect the capacitors in series or in parallel. In series means we connect a capacitor, then you connect the next capacitor, then you connect the next capacitor to a voltage source. This is connected in series. And I hope you guys know this one. So I'm not going to give you a lot of idea about this. So when you connect a capacitors in series, the total capacitance will become less. This will become 1 by C1 plus 1 by C2 plus 1 by C3. This is the total capacitance. 1 by C total equals 1 by C1 plus 1 by C2 plus 1 by C3. This is the total capacitance when we connect capacitors in series. When you connect capacitors in series, like the resistors connected in series, we can say that the voltage across each capacitor, C1, C2, C3. So these are three different capacitors, and these three different capacitors are connected across a voltage. source. So the voltage across each of them will be different. So V1 and V2 and V3, it is going to be different. Now we can say that V is equal to V1 plus V2 plus V3. Okay, so when we talk about the capacitors here, we know that if there is a negative terminal of the battery, from the negative terminal of the battery, the electrons will be pushed and these electrons will be loaded to the capacitor. So here I can say that this capacitor, the capacitor C3 will be having electrons overloaded. 1, 2, 3, 4, 5, 6. Let's see that. So if when 6 extra electrons are loaded on one plate of the capacitor, that electrons will be repelling the electrons from here. So here, the electron over here will be left, and that electrons from here, this electron will load over here. So the electron from here to move over here, this electron will move over here, this electron will move over here. So since there are 6 electrons on one plate of the capacitor, the other plate of the capacitor will be having 6 absence of electrons, and that electrons will go to the next capacitor. So here it will be 3 more. And then what happens? The electron from here will be left. This 6 electrons will be left, and this 6 electrons will add to the other plate of the capacitor. So from here, the 6 electrons will be left. That we can imagine that that electrons has gone to the battery. So this is how the capacitors get charged. So in this case, what happens, since the capacitors are connected in series, the charge on each plate of the capacitor will be same, because we can see that the electrons are leaving one of the plate of the capacitor, and that electrons will get into the other capacitor's plate. So if 10 electrons are left, or say 10 electrons leave capacitor number 1, that 10 electrons will get into the capacitor number 2. So capacitor number 3 also. So each capacitor will be having the same charge. The charges will be, charges are going to be same. Did you understand that? I hope you understand. So when you connect the capacitors are in series, the charge on each plate of the capacitor will be same. For example, if the first capacitor has got 100 coulomb of charge, then the second capacitor, third capacitor, every capacitor connected in series will be having the same charges, because the movement of electrons are taking place over here. So if 10 are left, 10 will be loaded. 15 are left, 15 will be loaded. That's it. So here we could say V is equal to V1, V is equal to V1 plus V2 plus V3. And we know that V is equal to, C is equal to Q over V. So V is equal to Q over C. So that's total voltage can be written as total charge divided by total capacitance is equal to V1 can be written as Q1 over C1, V2 can be written as Q2 over C2, V3 can be written as Q3 over C3. But we know that in a series capacitors, when capacitors are connected in series, the charges on each capacitor will be C. So this is all going to be C. So I can cancel this one, all going to be Q. So 1 by C total is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is how, when we connect capacitors are in series, the total capacitance actually decreases. Now capacitors connected in parallel. So here I can say that there is a battery. I'm going to connect a capacitor like this. Then I'm going to connect another capacitor of here. This is C1 and this is C2. Here what happens, you know that the capacitance of a capacitor depends upon epsilon 0 A by D. Look here, when we have got two capacitors, like here, this is first capacitor and the second capacitor. When they are connected in series, it's actually, we are connecting a capacitor like this. Look here, both capacitors are connected like, it's actually, it's kind of, we can say that we are connecting plate A of the capacitor with this plate. So what happened? The total length of the capacitor increases. When the total length of the capacitor increases, we can definitely say that the capacitance becomes more. Capacitance become more. So when we connect the capacitors in series, the total capacitance always increases. So we can say that C total is equal to C1 plus C2 plus C3. Because when we connect the capacitors are in series, it's like we connect this one and we connect this one. So it looks like a single capacitor with a long, length, with a greater length. So we know that if the greater length means the greater area, so the capacitance will be more. So when we connect the capacitors are in series, the total capacitance increases. Okay, now it is exactly opposite to that of the resistor. In resistor, when we connect in series, the resistance increases. Here, capacitor, when we connect capacitors in parallel, the capacitance increases. Okay, now that's it. Capacitors and okay, so here also there is a derivation that I think it's pretty easy for you guys. So that's what all about capacitors. And now it's about discharging capacitor. I will make another video.